For this demonstration, we will be using ParaView Catalyst capabilities on standalone case here, which is now available in examples runs, examples, tutorial, catalyst. So this is the same case as there. You've seen here base run, cooperates, examples, and the case setup here. This can be run by running a standalone, and we will be running also the same here. So this is an environment for runs, examples, catalyst. So we will be running this as this SOLPS HPC login 5. We will somehow remove unnecessary files. And that is usually enough for running a standalone case. In this directory, you will also find coprocessor examples, which we will need to run catalysts. So we will copy one basic coproc example into this directory here. And in this coprocessor Python, we will need to set up host name. So this is a default coprocessing script which is running inside the SOLPS B2.5 code, describing what kind of data is transferred over network to ParaView Catalyst. Since we have HPC login 5 node here, we will replace this host name here with the correct one. This is the only thing that we need to change here, and this is needed because if this is run at the cluster, usually in a batch mode, then this coprocessing routine sends visualization data to ParaView through the channel, and this is the position where our ParaView is running. The code can run by itself, or it can be run with ParaView or without. So if ParaView is loaded and is accepting connection from the code, then this coprocessing will send notifications to Catalyst and it will connect. Once again, we will copy into the correct directory So in this directory we can now run the code. Usually this is run as a standalone, but for demonstration purposes we will run it on the same login node and not under the batch, so that we will see how it runs. B2 -s B2mn, and this will print a lot of messages. So the code is usually, this case is running for 5 or so minutes depending on the uh, processing speed. So you see that it is starting and it's running actually. So this code is running, and we can module load paraview, and paraview will start in another window. And you see here catalyst in menu, and we will start a server on this port. So these two numbers for the port needs to be the same in both codes, and it is accepting connection to the coprocessor. Still the code is running, and you immediately see that we have got an input when we started the catalyst. This means that we already are able to extract some data. So by clicking on this input, we will extract input, and immediately you see the profiles from Edge code, so from ITER case, or actually this is ASDEX upgrade case, where we can have all these fields available. So electron temperature, for example, is here, and you see that we have got connection from the code to the paraview catalyst while the code is still running. So the code can run because it is compiled with paraview catalyst, and if paraview is connected or running and is listening to the connections, you see that it can run and so on. So we can set a breakpoint or pause a simulation. So that means that we can debug and so on. Or set a breakpoint at some specific step. For example, at 500 we will stop, and we will continue the simulation, and now you can see in set breakpoint that it is approaching 500 step where the code will stop, and at that point we can see, also inspect the values or whatever. So actually paraview catalyst is quite useful for, let's say, preparing or debugging, preparing some data and so on. You can even run the code in such way that you extract some for each step. So now that we have stopped the case, we can analyze or prepare different pipeline here. So the pipeline here, we can add some additional tool to create this co-processing pipeline script, and then we can use this script without having ParaView loaded, and it will prepare us, let's say, extraction of data into files, or it can create some movie and so on. For that, we will include uh, additional plugin, which is Catalyst Script Generator plugin, which will load here. Now you see here this loaded, and after we have loaded this, you'll see two additional menus here. One is writer, the second is export the script for the co-processing. And that means that this script needs not to be written manually, except that host name and port as the last line. So we can have a poly data writer here and write each step at that point. Or we can change write frequency each 5 cent and so on. And this will then be written in the pipeline, and we can then use this script instead of coprots.py. So we will create this script, show, and then you can configure what would you like to have. Live visualization is what you usually have, and then we have additional rendering or cinema, so Panga graphic files can be created, and that's all. And then we save this coprots file somewhere. Actually, this coprots file needs to be saved into the directory where the run is. If this file is not existent, then co-processing routines will not be called at all. This is additional optimization, so no penalty in the running of the catalysts is done if these files are not present. So we will just continue, or until we finish. Let us check how this file is different. Now we have this original file, and we will just unify the diff show coprots file, and on home directory my coprots py file. You see that at the end still the live visualization is needed to be changed if it is running on the cluster, not on the local host. And some additional Python scripts are being added as a pipeline. So whatever it is shown in ParaView here, it is then saved into this Python script. So this is graphical programming of the pipeline. So data, you can even see the file name and all that. Register writer, polydata writer, and file names, everything that was done as a filter there or a writer there, you can see in this script. So this script can then be used for different purposes. So let's say I can replace this script from home and overwrite it. And then if I repeat the run, then this script will be running ParaView in background without graphical interface. So all this Python scripting are somehow embedded into SOLPS-ITER code, and ParaView is actually just let's say graphical front end for the graphics pipeline. So in fact, this means that where you have a lot of data, you can add additional filters, like you can see in tutorial here, um, where you can extract just data that you want. For large codes, this means that you don't need to modify the code to get what you want. And then at the end, you can create visualization through ParaView for debugging and so on. So this is the end of Catalyst processing, and you see that their connection was broken. Actually, the code finished here, and that's why the connection has shown as could not receive any more data. So ParaView in principle receives one step at a time as the code is running, and you can create, let's say, debugging, timing, and each steps are then saved in one file or many files, and then you can create out of that animation, even analyze it in ParaView or create movie as a demonstration on how this code is evolving. That's a short introduction to ParaView Catalyst. More of that you can see how to use ParaView itself in the documentation itself, where you can read how can you further add that filters to get correct graphics pipeline. Thank you.